Hello everybody. Now we are going to talk about Ohm's law. Actually, Ohm's law is one of the most fundamental concepts in electricity. Actually, it's applied in many elements of the circuit, and we're going to just learn what it is, and we're going to see how we can apply it in a circuit. Okay, so what does a circuit look like? Let's see. Circuit has some wires, okay? And in these wires you can connect a battery. This is the positive side, this is the negative side, and you will have something, we call it the switch, and we also have an element, whatever that element is in the circuit. Could be a light bulb, could be the volume on your radio, could be whatever. So, and you are going to close the circuit. Okay, once you close the circuit here, what happens is that the current is going to rush from the positive side, and it's going to go through whatever that element is, and it's going to go back and close the circuit. Now we are going to find out the relationship between the voltage and the current, and that's what Ohm's law is focused on. So in this kind of like scenario, we found out that when the voltage increased, it was found out that the current increased too. Okay, and for this certain circuit where Ohm's law applies, if you can like draw the relationship between the voltage and the current, it would be found out to be like a very straight line with a certain slope. Okay, and the slope, as you know, is equal delta V over delta I, or for simply, you can just think about it as V over I, and that was found to be constant. So V over I is a constant. Basically, it's not changing, going up and down like that. So that's not the case. It is actually a straight line, and this line also, as you can see, it goes through the zero. That's very important. What it means when it goes through the zero is that when the voltage is zero, so the battery does not exist, basically, there will be no current. That's what the zero means. Okay, so V over I is equal to constant. So I'm going to write this again. V over I, the voltage over the current, is equal to constant. And Ohm, the person who studied this relationship, said this constant, I'm going to call it the resistance. And so V over I is equal to R. I'm going to call it R. And maybe it's best to write it in one line, so cross multiplication. So we find out that V is equal to I R. And this is a very, very important equation. I think you should memorize it, because this is very important. This equation tells us that the voltage difference across an element in a circuit, this voltage difference here, is equal to the amount of current I that goes through the element, and I'm going to call the element here R, the resistance. What it means that is that as the current goes through the wire, let's say the current is going through the wire like this, I, it's not going to go like move freely. Think about the current as a fluid or water going through a pipe. It's not going to gush freely, right? Because the pipe has limits, right? Has constraints here and here. It has boundaries. So as the current is rushing through the wire, it's going to be slowed down by the resistance or the friction in the pipe, if the water in pipe. Okay, the same thing. Current in an element basically is going to be what? Slowed down. So we think of that as a resistance to the current to move freely from one part of the wire to the other. As you know, think about the charge. We know by convention it's the positive charge. As it's going through the material of the wire, it's hitting other charges. It's interacting with the walls of the wire. It's doing this, so it bounces back and forth, and that's what it is actually. It's the resistance. Okay. So the voltage difference across this element will be equal to the magnitude of the current times the magnitude of the resistance. All right, and this is a very important equation, as we mentioned. Now to find the resistance unit, so I'm going to say R, the resistance unit, is equal to the unit of the voltage difference divided by the unit of the current. And we learned that the unit of the voltage difference is V, and the unit of the current is amps. So the unit of R, the resistance itself, is V over amps, but in honor of Ohm, who studied this concept, we're going to call it Ohm. And Ohm is kind of like interesting, kind of like to write, so we're just going to use this symbol, the Greek symbol Ohm, for Ohm. Okay, so this is what it looks like, and if you want to see how it's written, you can write it again like that. Okay, that's Ohm. So the resistance value is measured in Ohm. So now the current is measured in amps, the voltage is measured in V, volts, and the resistance is measured in ohms. Okay, let's actually, for the sake of an example, let's say that the current going through from the battery here is 0.1 amps, and the voltage of the current going through the wire is 0.1 amps. The voltage of the battery is, let's say, 9 volts. Let's find the resistance of this element. So as an example, R will be equal to V over I, and V is 9 and I is 0.1, which means now we have 90 ohm resistance. Okay, you should think about it. When the resistance goes up, the current goes down. Okay, so that's a good thing to think about. Okay, thank you.